So now that we've learned how to calculate the final vector and the magnitude and the direction, these individual parts, using our x and y components, let's take the final vector and find the x and y components. So we're given vector j, and its magnitude is 9 meters, and its direction is 40 degrees off the x-axis. Let's go ahead and take that and find our x and y. So we have an x component here. We'll call this j of x, and we have a y component as well, and we'll call that j of y. Let me go ahead and write that correctly, j of y. There we go. We can calculate both of those pretty simply. J of x will just be, well, we'll use our old friend, SOHCAHTOA, to help us find it. So to find j, we're using the adjacent and the hypotenuse, so we know the hypotenuse, we're looking for the adjacent. So that would be cosine. Cosine of angle 40. That'll equal the adjacent, which is j of x, over the hypotenuse, which is 9 meters. So from here, it just becomes a simple algebra problem. We'll multiply both sides by 9. This will cancel out on this side. We'll multiply by 9 on this side as well. And we just get 9 times the cosine of 40. So we type that in, 9 times the cosine of 40. And we'll get j of x equals about 6.9. Let me pick my right color here. There we go. J of x equals 6.9 meters. Can't forget the units. And then we do the same thing for j of x. We just use, since it's opposite to our angle, we would do sine. Sine of 40 equals j of x over our hypotenuse. Sine is opposite over hypotenuse, so 9 meters again. And so what we would do is just multiply by 9 on both sides. So we multiply by 9 over here, it cancels out. We multiply by 9 over here, and we just type that in, 9 times the sine of 40. And we get for our x component about 5.8. So j of x, or j of y, not the x component, the y component is 5.8. And I'm sorry if I said this was the x component. It is the y component. And if you're confused, you just look which way is it going, what's going up, so it's the y component. So from there, let's try our vector k. Let's find its x and y components. So we have a y component here going straight up. We'll call this k of y. And we have an x component right next to it. We'll call it k of x. And to find each one, we just look. Well, this is 35 degrees. Well, k of x is the opposite. If I want to do k of y, we do adjacent. So I can use sine or cosine to solve for one or the other. Well, let's just go ahead and start with sine. So we know k is 17. Let me go ahead and rewrite 17 on the outside there so we can see it. So that's our hypotenuse is 17. So we would say the sine of angle 35 equals opposite over hypotenuse. Opposite is k over x. Or not k over x, k of x, and the hypotenuse is just 17. So we multiply by 17 on both sides. We multiply by 17 on the left, or on the right, I'm sorry. We multiply it by on the left. Those cancel out on the right, and we do 17 times the sine of 35. So 17 times the sine of 35. If we get an x component, k of x is 9.8. We get the right color again. K of x equals 9.8. An important note is that x component is negative. It's going to the left, so that makes the x negative. And you'll see why in the next video, why that negative is so important. But from there, we can solve for the y. And we can use just the cosine to do it, or we could do a squared plus b squared equals c squared. So let me get my color back. Let's do a squared plus b squared equals c squared. Okay, well, we can rewrite this as c squared minus b squared equals a squared. Well, c is just the hypotenuse, which is 17 squared, minus b squared, we just said was 9.8. So let me go ahead and write that in the right color. It didn't pick the color there. There it is. 9.8 squared equals a squared, where a squared is k, or a is k of y. And so we literally just type this into our calculator. We'd say, what, 17 squared minus 9.8 squared. And we get 192.96, and we just take the square root of that. 192.96. And we get about 13.9. So k of y is 13.9. Now, you could have done a squared plus b squared equals c squared here for the second answer, and you could have done cosine over here for this second answer. It doesn't really matter. You can use any rules for solving for triangles to solve for vectors as well. And so a perfect example of that is with vector L. Now we're given L is 6, and we're given it's 30 degrees off the x-axis. And we can do sine, cosine, and tangent, or we could remember our rule about 30, 60, 90 triangles. If we have a triangle that's 30, 60, 90, let me go ahead and flip this. There we go. We have this sort of triangle, and we say that it's 30, 60, 90. We know that the sides are 1, 2, and the square root of 3, where the square root of 3 is just some random number, like, what is this square root of 3? I don't remember. Square root of 3 is just some random number that's equal to 1.7, basically. Well, what we do with this is we will substitute, and we will use proportions to figure out. So the hypotenuse is double the side of the smallest side. So we have an x and y component here. We have, let me get my pencil out. We have a y component here. We'll call this L of y. Well, that's the smallest side. So that would be half. Since 1 is half of 2, then L of y will be half of the hypotenuse, vector L. So this will be 3. And actually, it'll be negative 3 since it's going downwards. Downwards, okay. And our x component, which will be a positive x, well, that'll be whatever 3 times the square root of 3 is. Since, I mean, it's going to be, if this is tripled and this is tripled, then this number will be tripled as well. We'll multiply it by 3. And so we'll take the square root of 3, which we just found. We'll multiply it by 3, and we will get our x component of about 5.2. And it's a positive 5.2. And so now we found equals L of x. We found our x and y components of each one. And let me go ahead and just box our answers real quick. L of x equals 5.2. L of y equals negative 3. We got k of x equals negative 9.8. And we had k of y equals 13.9. And then, of course, these answers as well.